Hello class, this is a quick video on reactions with acids and bases. One thing we really want to talk about is double replacement. That's what when we have ionic reactants who separate their ionic charge and reassociate. So then we have positives going with negatives and negatives going with positives, and we're switching. So this occurs with acids when they react with oxides, hydroxides, carbonates, and bicarbonates. Oxides, hydroxides, carbonates, CO3, and bicarbonates, HCO3, 2. Cool. So as you can see here in our first one, our product is going to be our anion from the first molecule bonding with the cation of the second molecule, right? Creating CuCl2. And vice versa, the cation of the first molecule bonding with the anion of the second molecule, creating H2O. That's what we're talking about here. Double replacement switcheroo. Excellent. So for all of these that go through, now just some hints to remember, things like this, these twos, they don't carry. Right? At that point, they switch and they create 2CO2. So this one's a little bit more complicated. Take a look at it. We'll talk about it in class. But remember, these subscripts don't always carry. Cool. Equations with bases. Bases also go a double replacement reaction when they're with an acid. So a characteristic base is a hydroxide. And if it's a strong base, it's a hydroxide bonded to the first group on the periodic table. They still go through a double replacement, as our cation bonds with the opposite anion and creates another molecule, as well as the anion from the first molecule bonds with the cation on the second molecule, creating water. Now, this is a very characteristic equation you need to know. This type is called a neutralization solution, or neutralization reaction. What we're talking about here is acid plus base equals a salt plus water. This salt is usually a solid. We can't precipitate out of solution. And this is usually a solid. Can precipitate out of solution. We've seen this stuff before. And we neutralize the acidity of the acid and the basicity of the base at the same time, producing water. So our final pH of our solution in this scenario should be around 7. So when we talk about neutralizing an acid, we add a base. To neutralize a base, we add an acid. And the product, most importantly, some kind of salt. Now, just because we say salt in chemistry doesn't mean it's always NaCl. It could be a lot of different types of salt. So keep that in mind as we go forward. Again, this is a quick review. Double replacement reactions allow us, or our imaginary hypothetical reaction, everything separates. All of our ions separate from each other, like here, and then they reattach. Now the question is, how do we know which one to write? Mr. Bridgewater, I don't know which one you're talking about. If you ever don't know, just write both. H plus to OH minus equals H2O, and then of course, Na plus CO minus yields NaCl. Cool. We have single replacement, of course. I think we've seen this before. This one comes in here, kicks that one out, bonds it there, leaving with just the hydrogen. When this is, remember, based on our strengths of metals chart. Cool. Salts. So salts are really important. Salts can be acidic, they can be basic, and they can be neutral. Salt is more or less the product of an acid and base reaction. So a lot of times if you start with HCl, we'll have a Cl as a salt. If you don't, then you don't. Here we go. Here are the reactants of NaCl, of course, salt and water. HCl, strong acid, NaOH, strong base. resulting they neutralize each other, creating a neutral salt. Now, if we have HNA or HC2H3O2, which is acetic acid plus sodium hydroxide, what's our product? Well, we have a weak acid plus a strong base. Now, the base is stronger, creates a basic salt. Another way I like to think of it is a strong base creates a basic salt. So SB equals BS. Yeah. So SB equals BS. Strong base equals a basic salt. Strong acid equals an acidic salt. So we look here. We have HCl plus NH4OH. Excellent. Producing NH4Cl. Well, we have a strong acid plus a weak base, providing us with an acidic salt. So strong acid makes an acidic salt. Strong base makes a basic salt. Strong acid, strong base is neutral. That's it. Some quick equations you might need to recognize. Okay, so here we go. Actually, I'm going to talk about this on the next video. Yeah, so I'm going to back up here. I'm going to end it here in this video. Here. This is just salt hydrolysis, and we'll catch up on those ones on the next video. Great. Have a good day.